In 210, we're going to wrap up the trig derivatives, and we're going to start with what we had done previously, which was the derivative of sine is cosine, and the derivative of cosine is negative sine. So here are the other four. Derivative of tangent is secant squared. Derivative of cotangent is negative cosecant squared. Derivative of cosecant is negative cosecant x cotangent x. And derivative of secant x is secant x tangent x. I'm going to prove the first one, and then the other three, you could actually do the proof by yourself. So what I know is tangent is sine over cosine. Again, I know tangent is sine over cosine. Now I have the derivative of a quotient. So here I have this step. And then let's tidy that up. That's cosine squared x plus sine squared x. And let me refresh your memory. When you square a trig function, we put that little 2 in the, like just above that letter S, and write cosine squared x. Anybody remember their trig? What's cosine squared x plus sine squared x equal to? 1. Nice. And then what's 1 over cosine squared equal to? Secant squared. All right, so let's maybe remember this one. Sine squared x plus cosine squared x equals 1. That's called our Pythagorean identity. We're supposed to remember that. So let me pause a moment, and I want to give you a head start on example 1, A and B. Use your new trig derivative to find the derivative of each. So letter A, that's 1 minus secant squared x. Now, on tonight's homework, you're going to notice that it's this acrostic puzzle, and it has, even though they're multiple choice, I do want you to show your work, but it's going to be an excellent example of what I've been talking about. Is like, this is a correct answer, but that is not going to be one of your multiple choice answers. So I want to show you how you can manipulate to get there. So if we remember our Pythagorean identity, that sine squared x plus cosine squared x equals 1, if I happen to divide both sides of that identity by cosine squared x, that's tangent squared x plus 1 equals secant squared x. And if I subtract 1, I'm almost there to what I have. If I multiply both sides by negative 1, now I have it. So This could be an example of 1 minus secant squared x isn't a multiple choice answer, but negative tangent squared x is. So you will have to be able to simplify and manipulate with your trig. So I'm trying to bring this back and show you how it's done. But for me, on a free response, y prime is 1 minus secant squared x. That's correct. There's nothing wrong with that. For letter B, this is going to be my product rule. So this is a correct answer, but they might have it written like this. Anytime you can factor, they oftentimes will do that in the multiple choice section. All right, moving along, the 3 trig identities. We've done 2 of them so far, which were sine squared x plus cosine squared x equals 1. We had tangent squared x plus 1 is secant squared x. The third one, I'm going to go back to my Pythagorean identity, and if I divide by sine squared, that develops my third one. So what I do is I just remember sine squared plus cosine squared equals 1, and I can do a quick manipulation to get the other 2. So there is going to be a lot that you have to memorize and remember. So these other 2 are not ones that I want us to try to stick in our brains, because our brains are going to be full of everything you have to remember. These 2 I don't put in my brain. I use this one, and then I do a quick manipulation when I think, okay, I can't see my answer, or I don't know a next step, what can I do? And then I draw these back out, okay? So that's just a suggestion. If you want to memorize them, you're welcome to, but I really don't recommend that. Okay, now we're going to do kind of a fun activity. I have a trig identity. There's a left side and a right side. What I want you to do is at your table, you usually have, I think, 2 people. So Taj, if you'll do me a favor, and if you'll pop over here, you can either be with Nicholas or Ben, you choose. And then everybody else has a partner. So you decide, and if you have to rock, paper, scissors, somebody does the left side derivative, the other person does the right side derivative, and then I want you to compare your answers to see if you got the same thing. So decide which side you're doing. All right, I'm starting the left side. I'm using my quotient rule. Okay, left side people, did you get this? Oh, right side people, you lucked out. Like, do you see those are in fact the same? Yeah. Yeah, so right side, that was the easy one. The left side was much harder. All right, questions on that one? Not bad. All right, example 2. It says let y equals x cubed tangent x. Find the slope of the line tangent to the graph of y at x equals pi over 6. So let's do this. And we're going to do a little bit of simplifying. I only wanted the slope. We're not going to simplify it the whole way, but we are going to at least do what tangent pi over 6 and secant pi over 6 are. Otherwise, it's nasty. I didn't intend to do such a thing. But like this would be no calculator. So I want us to see how you do this without a calculator. So I'm going to draw a 30-60 right triangle. This is 1, 2, square root 3. Secant is the reciprocal of what trig function? Cosine. So if cosine of 30 is radical 3 over 2, then secant is 2 over radical 3. Tangent would be TOA, so that's 1 over square root 3. And I'm just going to leave it like this, okay? Super ugly, but true. Three times pi over 6 squared. Pi over 6 squared would be pi squared over 36 times 3. I don't want to simplify it. It definitely could simplify, but I'm just not going to touch it. All right, in example 3, find the instantaneous rate of change of g. What's another word for instantaneous rate of change? Derivative, right? It's the derivative. So we'll do and again, we're not going to simplify this. We're just going to get this first part set up. Because you would definitely have to do this on a calculator. But we're just going to go to this point. All right, example 4 says find f prime of pi over 6 if f of x is x over secant x. I'm going to give you about a 1-minute head start on me. And I want you to try to do your derivative, then plug in. Don't touch a calculator. And I did simplify this one because I wanted you to see one where they might do that and do a multiple choice question that takes you a little bit further. Then when we finish this one, you'll have the rest of the period to work on the 210 worksheet. It's not too bad. Now, there was kind of an easier way to do this one and a harder way to do it. If you notice that you had a common factor of secant x, before you plug in pi over 6, you can cancel one of the secant x's. And that just makes the work a lot easier. All right, so tangent pi over 6 is 1 over radical 3. Secant pi over 6 is 2 over radical 3. Now, when you divide by a fraction, that's the same as multiplying by the reciprocal. And that actually worked out kind of nicely here, because then when I distribute radical 3 over 2, the radical 3's cancel in that second term. Now, suppose this wasn't one of my answers and it was a common denominator of 12. I could, in fact, multiply the first one by 6 over 6, and I could see that.